Hi guys, in the last few weeks we've had a look at virtual matrices and how to set them up in FPP. Today we're going to have a look at how to set up a panel matrix, in this case a P10 matrix just here. We're going to set it up in FPP version 9, xLights 2025-06, and we'll get them both working together to get a nice butterfly up and running by the end of the video. Now the panel I've got here is a pre-made panel purchased from a company in the Far East, and it's already been set up with a power supply with the panels, and it's using a Colorlight card like this one here. Now this Colorlight card has already been configured by the factory for the panels, so I don't need to do that today. But if you're doing a DIY panel and you've purchased the panels and the Colorlight card separately, then you will need to configure the Colorlight before you get to this stage. Now I've already done that in the past. We've got a video on that pre-done, and I'll stick a link to it up here right now. So let's get into it. This panel is two 320 by 160 panels wide by 4 high, and they're P10 panels, so they are 32 pixels wide by 16 high with a 1/8 scan. So they're connected to 4 of the outputs on the Colorlight, so they're arranged, each row of 2 panels is connected to 1 output on the Colorlight. Now that shouldn't be necessary, we don't really need to know that bit, but I just thought it would give you some info. Now I've got an Ethernet cable already connected to the panel, and that's appearing on over there just on my desk at the moment. And we're going to connect it to the Raspberry Pi 4 here, which we've got ready and waiting. And I'm going to use a U-green USB to Ethernet adapter to hook it up. Now I'll stick a link to this in the chat as well. This has come from a very well-known online store that delivers next day and is owned by Mr. Bezos. I'm going to start on FPP first. We'll get that configured and ready to go, and then we can configure xLights to match the settings that we've set in FPP. The first thing we're going to look at is FPP. So let's dive straight into that and get that configured. If I go into Status Control and Network, we can see that we've got 2 interfaces here ready for use. Now I'm not using the wireless interface on this demonstration. I'm using the wired interface to connect to my show network. Now we can't use that regular show network to communicate with a Colorlight card, even though it uses the same connectivity type and a Cat5 cable with an RJ45 on the end connecting to an Ethernet adapter. It uses a different communications protocol to our regular Ethernet, and if we tried to connect it to our regular show network, it's just going to mess it up a treat, because it chucks loads of specific packets on there which are not routable. They don't behave in the standard way that Ethernet does. So we need to keep them separate, and to do that I'm using the Ethernet interface here, the U-green USB adapter. So I'm going to plug this in first of all. Now on the Pi 4 it doesn't matter which USB connector we use, so I've just plugged it into the first available one, and after a few moments that will be ready for us. If I go to Status Control Network again, there we go, that we can see that we've now got an ETH1 added to the mix, as well as our ETH0 and our wireless LAN. Now the first thing I want to do is I want to make sure that these ports don't move around. Because of the way that Linux boots and it finds different things, it is possible that it could find our USB Ethernet adapter and set that up as Ethernet 0 before it finds the onboard Ethernet adapter and then labels that as ETH1. And if that happens when you reboot your show at showtime, all your settings are going to be wrong because your home or show network is going to be trying to use the Ethernet adapter that's connected to the Colorlight card and vice versa, and it just ends in a muddle. So we can fix that. If we go down to the bottom now and we go to create persistent names, yes please, and it wants a reboot, thank you very much. That will then have a look at the individual devices and we'll create static links to them so that whenever the Pi reboots, it will always have the right interfaces in the right places and we won't end up with the wrong type of communications going to the wrong port. Now, as soon as this has finished rebooting, which won't take a moment, we can then step right in and get things configured. There we go, the Pi has finished rebooting. So I'm now going to, we're still able to talk to it, so that's a good sign that our connectivity is correct. And I'm now going to bring in my Ethernet cable that I've got ready that is connected to my Colorlight. There we go. That's all plugged in and that is now all ready to go. So let's get the Colorlight configured. At the top here we can see that it's come up with an IP address. It's in the 169.254 range, which means it hasn't found an IP address, but that doesn't matter because the Colorlight doesn't use IP addresses anyway. So I'm going to go for input output setup and channel outputs. I'm going to go to LED panel matrices and we're going to set up our new panel here. I'm going to enable it and then I'm going to start configuration. So our connection type is a Colorlight card and we're connected to ETH1. If in doubt, have a quick glance at the top. Our first one here was ETH0 and that's connected to my show network, and then the second one has got the random IP address. So it's ETH1 here that we're using. We can give it a name, so I'm going to give it a name of demo, I can't type, P10. Okay. Our panel layout. Now this is the number of panels that are being used in terms of width and height. So as I said at the beginning, we are 2 panels wide by 4 panels high. They are 32 by 16, so that's 32 pixels across each by 16 pixels high, giving us a total of 64 by 64, or 4096 pixels in all. We're starting top left. Our gamma can sit at 2.2 and the brightness I'm going to leave at 100% because the lighting in here is quite bright and they're going to have to compete with that. Now before I go down any further, we get to LED panel layout. So I am going further, and as you can see at the moment they're all set up for output number 1 and panel number 1. So this would imply that everything is connected to output number 1 on the Colorlight card and panel number 1. So they're all going to display exactly the same thing at the moment. Now in times gone by we had to go through and manually configure all of these, which isn't too bad for 8 panels. We just got to go in and say panel output 1, panel 1, output 1, it's probably panel 2, and so on. But it's easier these days. We have the auto layout feature at the top here, and I'm going to say yes please to that. And then once we've done that, we can scroll down and we can see that all our outputs have been assigned conventionally. So the top 2 panels, panels 1 and 2 on output 1, Then the next two are on output 2, output 3, output 4. So all good. Back to the top, our start channel is number 1. For this demonstration, I'm going to leave it as channel 1. It's often easier to leave an LED panel or a virtual matrix at channel 1 because that's not going to change very much. You might be moving props around and changing things further down the display, but if your virtual matrix or your real matrix is at the beginning, then that doesn't need to change. Our channel count, 12,288, which is 4,096 pixels. 4,096 pixels, of course, they're RGB, so 3 channels each is what gives us our 12,000. And the default panel color order. Now, most LED pixels, your regular bullets, are in an RGB color order. So your first packet is for, or your first channel is for red, and then you've got your green and your blue. Panels are typically BGR. So blue, green, and then red. We'll put it on that and we'll test it in a second and we'll confirm that. So that's all done. That's your output configured in LED Vision. So I'm going to save that now. And yeah, unsurprisingly, it wants a restart of FPPD. There we go, FPPD has now restarted and it should have all of the configuration required now for our panel. So we can stick the panel into test mode. So I'm going to click the test pattern button here. And that has not worked. Why has that not worked? We are enabled, we're on Colorlight. It's still telling me that I have unsaved changes, so I'm not quite sure what it thinks is unsaved on this. I'm going to save and restart FPPD. The connection all looks good. Okay, let's do a test again. Right, I'm not quite sure what FPPD was up to there. I saved it for the second time, restarted FPPD again. Hit test pattern, and this time it's come up fine. So we can see the test pattern is running now. We've got panels 1, 1, so that's panel 1, output 1, output 1, panel 1, output 1, panel 2, the same for rows 2, 3 and 4. Now the thing I like to check at this point then is that, I meant to stop that and I press save instead, so let's just do a restart. Oops. The thing I like to test at this point then is our color order. So we make sure that our color order is correct. So if we go to status control and display testing, we can then put it into a cycle pattern for RGB, so for red, green and blue. And if I enable test mode, we get red, green and blue. There we go, red, green and blue. Beautiful. So that works perfectly. If you're not sure, we can go down to the solid color test patterns. So I can do a fill color. I can set it to red on its own. There we go. And then we can turn on test mode again. There we go. We've got red. And if I turn red off, we can do green and off. And we can do blue and off. Beautiful. That's working perfectly. So the panel is all set up now. It's ready to go. What we need to do now is we need to configure xLights, set up a panel matrix in there, and then we can create a short sequence, save it, push it to FPP, job done. So going into xLights, I'm going to start by doing a discover to find my controller, and the only controller on the network at this point should be my Pi. And there we go, it's found the Raspberry Pi, so that's ready to go. And we can see that it's already set up for LED panels, which is great. So that's our controller loaded in. Now we've got to put our model into the layout. So I've gone for the layout tab, and I'm just going to bring in a matrix model. There we are, and we'll drag that out to roughly a square because that's the shape of my panel. It's going to be about like that. There we are. And then we can run down the left-hand side through the settings. Our direction is horizontal, so that means that each of the strings on our panel is running side to side, so in horizontally. Now that's important. When we get down to the number of strings, that is not the number of pixels across. That is the number of strings, and each string is horizontal, therefore the number of strings is vertical. In this case, 64 and 64. But if you get funny layouts coming through or funny visuals, it may be that you've got your strings and your nodes per string the wrong way round. So your nodes per string is horizontal and your number of strings is your vertical. Strands per string is 1, starting location is top left. Happy days. We can save that. So that's really quite straightforward. We've just got to put in there, we've got to drag out the matrix model and set the number of strings and the number of pixels per string. Now at the moment it's telling us its start channel is 2. On FPP we had a start channel of 1, but that will fix itself in a moment when we use the visualizer to assign this model to the controller. So let's go and do that. So I've gone for the controllers tab, highlight my Pi, and then I can visualize and I can drag my matrix onto LED panel 1. There we go. And we can come out of there and save. And there you are. You can see that the number of channels has now sorted itself out. It's now 1 to 12,288. So that's our model set up in xLights. Again, really quite straightforward. Only thing left to do is to create a sequence. So I'm going to create a new animation, 40 frames per second, quick start. Thank you very much. There we go. And I'm going to use the obligatory butterfly effect. So I'm going to drag that onto the timeline. And I can stretch that out to my 30 seconds. There she is. Beautiful. And there is our butterfly effect ready to go. So let's save this sequence. File, save sequence as. And where is this saving to? This is not saving to where I want it to, so I'm just going to stick it into the right place. And overwrite one I prepared earlier. There we are. So that has saved the sequence. What I'm going to do now is I'm going to render it and I'm going to save it again just to make sure that we've got a good rendered copy ready to go. There we go, job done. Now we can go to Tools and FPP Connect, and we can push our newly created butterfly sequence up to FPP. There we go. Now it's given us an IPv6. I'm not sure what that's about, but it's not checked. Our player is correct that we don't need any media to go with this one, and I'm not playing with the UDP out at this stage. All I want to push is my P10 FSEQ, so I'm going to upload that. There it goes. Job done. So let's go back to FPP, and I'm just going to refresh this page, and there we go. Our sequence is now there, ready to go. And if I hit play, there we go. There is our butterfly sequence alive and well and playing on our matrix here. And that's all ready for your matrix effects. You can put text on it, put anything you like on it. It's all ready to go. So there we go. That's how to set up a real panel matrix in FPP version 9 and xLights 2025-06. As always, I hope you found that one useful. Next week, we're going to be looking at the new FPP functionality where we can run multiple matrices from one instance of FPP. So we're going to take what we've built today, we'll add another panel to it of a different form factor to P10, so probably a P4 or a P5. I'll see what's available. We'll get that hooked up, we'll add it to our xLights setup, combine the two into a group, and then we'll apply a sequence to the group, play it on here, so we get a unified output across two different panel types. So we'll look forward to that one. For now, take care, have fun, see you on the next one.